we're going to have a think now about the idea of centre of gravity. The centre of gravity is an imaginary point where, when we're trying to make calculations about whether things are stable or not, we assume all the weight of an object acts. So the centre of gravity is a point where all the weight of an object is assumed to act. So let's take some simple examples. Imagine we've got a square piece of paper. The centre of gravity would be exactly in the middle, or a round plate. Once again, the centre of gravity would be right there in the middle. And what that means is that if you spun that on its side and tried to balance the paper or balance the plate, to balance it, you'd have to put your pivot right underneath that point, and then it would balance. The centre of gravity is right in the middle. We use this idea when we're trying to understand what makes objects more stable. So, for example, if you were designing vehicles, then one of the things you might do when you're designing your vehicle is to design it so it has quite a low centre of gravity. Let's imagine that this is a side-on view of your car. You've designed your car quite a lot of the weight towards the bottom where the engine parts are, so the centre of gravity is quite low down in the vehicle. That's going to make that quite a stable vehicle, which is unlikely to topple over when it's going around corners. If on the other hand you were designing a double-decker bus, then the cross-section for that is going to be much higher, and the centre of gravity is going to be probably up there, perhaps not quite in the middle, but getting close to the middle. And that high centre of gravity means it's much easier for the object to topple over. So we need to think about centre of gravity when we're considering what makes objects stable. How then can we determine where the centre of gravity of an object is? Well, it's pretty straightforward, as I say, if the object is symmetrical. But let's suppose it's not symmetrical. Let's take a fairly arbitrary shape, plane, cut out of card, for example, a shape like that. Pretty difficult to say on the face of it where the centre of gravity is. Well, one thing we do know is that if I cut a hole in the corner up here, and if I attached it by a pin to a stand so that it's now able to swing freely, then when it comes to rest, the centre of gravity must be somewhere underneath that pivot point. It must be, because if you imagine it wasn't, imagine the centre of gravity was over here, then the centre of gravity would be where the weight is assumed to act. So imagine for the sake of argument it was there, then clearly that would be twisting the shape in this direction until it's moved and the centre of gravity is underneath the pivot. So a nice easy way to determine where the centre of gravity is just to hang a plumb line down like that with a lead weight on the bottom. Okay, straight down, and then somewhere along that line the centre of gravity must lie. Well, it doesn't tell us exactly, does it? But all we need to do then is cut a hole, let's say over here, move the card round and let our card swing freely, attach the plumb line again, and we'll get another line, and where those two lines meet, that's where the centre of gravity is. So an experiment like that enables you to determine the location of the centre of gravity even for irregular shapes. Now, I mentioned the centre of gravity is really important in testing whether or not things are stable, and we can see that if we imagine things on a slope. So I'm going to put a slope here, and again we're looking at a cross-sectional view. Let's look at my stable vehicle with the wheelbase quite wide and the centre of gravity quite low. The centre of gravity, as we say, is where we imagine the weight of the object is concentrated. We sometimes use a little arrow there to show the weight. And you can see that that weight is pulling the object and keeping it stable. It's actually anchoring it on the slope. But the reason it's doing that is because if you think about the corner of the object, the weight lies inside that corner, inside the base area of the object. The line of action of the weight is inside the base, and so we've got what we call stable equilibrium there. Now let's contrast that with a really high-sided vehicle, like a double-decker bus or something like that. I'm going to exaggerate the dimensions to make the point really, really clear. But let's imagine we've got a really tall, in fact I'm going to make it a bit taller and a bit narrower. Let's make it really long and thin to really make the point. And with a narrow base at the bottom, and let's imagine the centre of gravity is somewhere way up here for some reason. Then when I drop the line down, that now lies outside the base. Okay, so the effect when it goes on an angle like this is the effect of having the weight acting outside the base is to cause this object to start toppling over. Okay, so if the line of action of the weight is outside the base, then the object is unstable and liable to topple. The line of action of the weight is inside, we've got stability. And you see this principle then being used by, for example, in judo, a stance that you might take up in judo, you might widen your base by putting your legs apart and crouching down, so you've got a low centre of gravity and a wide base area to make you more stable. So the principle of centre of gravity is used as a way of helping us think about stability of objects and when they're liable to topple.